Alright, welcome in this video. Here we will solve a very classic DSA problem which is frequently asked in the big tech interviews, longest consecutive subsequence, right? So in this question we are given an array of non-negative integers and our goal is to find the length of the longest subsequence where all the elements or all the integers basically are consecutive, right? And these integers can actually appear anywhere in this particular array. They don't have to follow the right order, right? But just that they have to be present somewhere in this particular array, right? So just to make it clear, what we mean by a subsequence of consecutive integers is that, for example, if you see over here, we have 1, 2, 3, and 4, right? So that means we have all the numbers starting from 1 up till 4, right? All the consecutive integers are actually present in this particular array, right? And hence, this particular subsequence will be called as the subsequence of consecutive integers, right? And this will be considered as a valid subsequence that we are looking for in this particular question, right? Now, similarly, consider that in this particular input, for example, we also had another subsequence of consecutive integers starting from 15 up till 19, right? So in that case, that also would have been another subsequence of consecutive integers which is present in this particular array, right? And what we need to do is we need to find out all such subsequences of consecutive integers, right? And finally, we have to return the length of the longest such subsequence, right? So in this case, since we only have one subsequence of consecutive integers, that is 1, 2, 3, and 4, right, whose length is 4, so my output over here in this particular example would be 4, right? If I had more such subsequences of consecutive integers, then I would have taken the longest among all of those, right? So this is the question entirely. I hope you understood it well, right? Now maybe you can just pause this video and try to think of a solution, and once you are done, you can just come back and check the solution here. All right, now to solve this particular question, see what we can do is we can actually make use of a hash map over here to basically store and then track every unique number in this particular array, right? So first of all, we will just loop over this particular input array, right? And we will keep storing every unique number that we are getting in this particular array into a hash map, right? And once we are done with that, then for every number, again in this particular input array, we will first check if that particular current number, right, is actually starting a new sequence or not, right? And how will we check whether that particular current number is actually starting a new sequence or not? We can check this by checking if the previous number to that particular current number is actually present in the hash map, right? Because if that previous number is present in the hash map, it would mean that this current number is not starting a new subsequence, right, of consecutive integers, because the previous number is also present, right? So it is not the start of a new subsequence of consecutive integers, right? So that's what we can do. And if we are actually able to find out any valid start at any current number that we are looping through in this particular array, we will then expand the sequence forward, right? And we will start counting how many consecutive numbers actually exist ahead of it in this particular array, right? So what I mean is that, for example, if in the first iteration, if I'm at 100, first of all, I will check whether this is a valid start of a new subsequence of consecutive integers or not, right? And how will I do that? I will check if 99 is present in my hash map or not, which will be like a constant time lookup in the hash map. I will quickly check if 99 is present or not. If it is present, it would mean that this is not a valid start, right? Because the previous element is present. And in case if 99 is not present in the hash map, it would mean that actually this is a valid start of a new subsequence of consecutive integers, right? So now if you see, 99 is definitely not present in my hash map because it is not a part of this input array. Hence, I could say that 100 will be a valid start, right? And now I will just start expanding this sequence forward. I will keep checking if 101 is also present, 102 is also present, and so on, right? And wherever I find that a particular element is not present, that is where I'm going to break and I'm going to take the length up till there as the length of this particular subsequence. And then what I will do is I will compare this length of this particular subsequence that I found out with the maximum length that I've seen so far for any subsequence of consecutive integers, right? So over here, if you see, the length of this particular subsequence of consecutive integers, which is starting from 100, will be 1 itself, right? Because I won't be able to find 101 also in this particular array, right? So the length would be just 1, right? And what I will do is now I will just compare this particular length of this particular subsequence with the current value of the maximum length variable that I would be using to track the maximum length that I have seen so far, right? And whichever is greater, I will at any point in time assign that particular length back to my maximum length variable, right? So that's what we are going to do. That's what the algorithm will be all about. Now what we can do is, now we can actually start by initializing a hash map first of all, right, to store every element from the array. And then we can also declare a variable max length to store our result, right? And we can initialize it to 1. And why we can initialize it to 1? Because, at minimum, the minimum length that I can get for any consecutive subsequence of integers can be 1, right? Which can have just one integer in that, right? So at minimum it will be 1. So that's what I'm just initializing to the maximum length variable. Now what we will do is, now we will loop through this particular array and insert each number into this hash map, right? And this will allow us order of 1 lookup time for checking if the number exists or not, right? And now after doing this, now what we will do is, now again we will loop over every element in this particular array, and for each element now we will check if it's a potential sequence starter or not, right? That is, if the element, the actual element, actual integer -1 is not in the map, right, in the hash map. And if it is a valid start, we will then begin expanding the sequence from this number, right? So that's what we are doing over here. Starting from the current element, we will check if the number exists in the map or not, right? If yes, we increment our count and check the next one, and so on, right? And we keep doing this until we hit a number that's actually not present in the hash map, right? And at each step, we will keep updating the maximum length variable if the current sequence is actually longer than the previous max that I've seen so far, right? So that's what we will be doing in this particular step. And also, like as we discussed, at each step, at each iteration, we will keep updating our maximum length. And now once we have looped through all the elements, maximum length will actually hold the length of the longest consecutive subsequence, right? And we will simply return this as the final answer. So this is the overall algorithm. This is the final solution that we are going to implement. And now talking about the time complexity and the space complexity. See, time complexity, we are just looping over this particular array twice, right? First for creating the hash map, and second for actually finding out subsequences with consecutive integers, right? So we are just looping over this particular input array twice, and so my time complexity over here will be order of n. And now talking about the space complexity, since we are using an extra hash map over here to basically store every unique number in the input array, the space complexity will also be order of n over here, right? So both time and space complexities will be order of n in this particular solution. So that's it. And now maybe let's code this particular solution. All right. So now let's code the solution that we just discussed. So first of all, I will start by declaring a function, and I will name it as longest consecutive, maybe like this, right? And this will accept an input array like this. And now what I will do is I will just capture the length of this particular array in a variable n, right? And now I will just declare my empty hash map like this, right? And I will also declare the max length variable and initialize 1 to it, right? Now what I will do is, now I will run a for loop in the range n to basically populate my hash map, right? Like this. And for every number, I will just keep making an entry in my hash map like this, right? And I will just assign the current index as the value for that particular number, right? It can be anything really, but then we can just make use of the current index, right, of that particular number. And now what we need to do is we have to again loop through this particular input array, and we have to find out if we get a valid sequence start at any current element or not. And if we do, then we will start looking up for the next elements, right, in this particular sequence by looking them up in the hash map, of course, right? So now what I will do is I will again loop in the range n like this, right? And now I will keep checking if my current element is in hash map like this, right? And of course it is going to be in hash map. And at the same time, I will also check if my current element -1 is not in hash map, right? Like this. And in fact, we can get rid of this particular first condition because, as I said, it will always be there in the hash map, right? That's how we have got it, right? So we will just check if the current element -1 is not in hash map. And in that case, we are concluding that this is a valid sequence start. So what we will do is we will just declare a local variable L to capture the length of the ongoing subsequence of consecutive integers, and we will initialize it to 1, right? And now we will also declare another local variable and we will call it as current, and this current will hold the very next element, right, to the current element, like this, right? And now what we are going to do is we will keep checking if this current is actually in my hash map, right? Because if they are in the hash map, like the next elements, then they will be a part of the consecutive subsequence, right? And wherever this particular condition is not met, it would mean that I have got to the end of the subsequence, right? And I can just consider whatever length I have got so far as the actual length of this particular subsequence, right? So now what I'm going to do is, if this current number that is starting from the next number, if it is present in the hash map, I will keep incrementing my local L variable, right, to track the length of the subsequence, the ongoing subsequence, right? And also I will just move to the next number in the sequence, like this, right? That's what we are doing. And finally, once we come out of this while loop, right, what we will do is we will just reassign the maximum length variable with the maximum between the maximum length itself, right, and this L variable, the local L variable that we actually updated over here to hold basically the length of the current subsequence that we have found out, right? Whichever is greater, we will just assign it back to the maximum length variable, right? So that's what we are doing over here. And once we are done looping over every element of this particular input array, right, once we come out of this particular for loop, what we can simply do is we can just return this max length variable like this, right? And that's it, right? This is our entire solution. This is the complete algorithm that we discussed. And now maybe what we can do is we can also quickly validate this particular solution by running it against a test case, right? So what I will do is I will just declare an array over here and I will initialize it with a sample test case over here, right, like this. And now what I will do is I will just print the output of this particular longest consecutive function when called over this input array, right? So over here, if you see, my answer should be 9, 10, 11, 12, 13, 14, 15, right? All these numbers actually form a subsequence. So my output should be 7 over here, right? So now if I run this, let's see what we get. And we actually get 7 over here, which is the correct output, right? So this is the entire solution. And now I will see you in the next video. Thank you.